Okay, so for question 5, what you need to be careful with is that you have to break this question up actually more, because in the question, when you read it, it's ice at -10 is that it's 5 grams of water at 75, and there is no loss to the surroundings. Calculate the resulting temperature of the mixture. Okay, so the problem with this question is that you can't change from ice to water unless the ice is at 0 degrees. So you need another step here. The ice has to go from -10 to ice at 0 degrees. Then it needs to go from ice to water. Then it needs to go from water at 0 degrees to water at X degrees. And all of that is equal to water at 75 degrees is what's losing energy, and it goes to water at X degrees. So important thing when you're thinking through this question, Shauna, is that you can't melt the ice straight off. Okay, and in order to change the temperature of ice, it actually has a different specific heat capacity. So the specific heat capacity of ice is actually only 2100. So it's easier to change the temperature of ice than it is to change the temperature of water. So if you look at it, it's the mass of the ice is, what happened there? Undo. Sorry about that. Okay, so when you actually fill it in, what you have is 0.3 times mc delta theta for the ice. So C is 2100. The change in temperature here is going to be positive, so it's 10 plus ml for the ice, 0.3 times latent heat of fusion, 3.3 by 10 to the power 5, which you had correct, plus the water is still ice, so it's 0.3 times, now it's water, so it's specific heat capacity of water, and the change in temperature of here is going to be X equals 0.5 times 4200 times 75 subtract X, and you're well able to finish it off from there. So just that, the only thing to be careful with is you have to break it into 3 stages if the ice is below 0 degrees. Alright, any questions, just ask.